Hi, Basic Physical Science. Sorry I can't be at class today. I have some meetings this afternoon. Here is your agenda for today. I want you guys to start by getting your notebooks out of the cupboard, and then the substitute teacher is going to hand out a worksheet for you to work on today. It's a review of all of Newton's laws that we were working on last week. We'll have most of the hour to work on that. If you finish early, here are the things I want you to work on, okay? I'm going to ask the sub to leave this part of the video showing during most of the hour today, so if you forget what you have as alternative activities, you can take a look up on the screen. I want you to update your table of contents for Unit 3. Fill in any gaps on the Unit 3 assignments that we've done so far, so the work that we did out of the textbook and the activities we did in class. And then if you finish those things, I want you to go through those about 5 or 6, 7 pages that we've had in this unit in our notebooks and highlight keywords on each page, like what's the main point on each of the pages that we did in our notebook. Toward the end of the hour, the sub is going to hit play on this same video again to do a little bit of a video review of the worksheet. This is all in preparation for tomorrow when we have a quiz on our Unit 3 material. Okay, so right now is time for the sub to pause the video and for you guys to get your notebooks and the worksheet and get to work. Okay, so we had a chance to work on the review worksheet. Let's go through a few answers on here and see if everybody's on the right track. All right, so the first question was asking you to write a definition in your own words for the word inertia, okay? And so inertia, you can think of it in a couple of different ways. You could call it mass. You could call it an object's like ability to resist changes in motion. That's a little bit more like the textbook definition. But really when it comes down to it, it's kind of like how big or small things are in terms of their mass. Okay? All right, the next question was, how can we make an object accelerate more? Remember what accelerate means. It means to change the motion, like speeding up, slowing down, or turning could be acceleration. So how can we make it accelerate more? Let's look at the options. We'll ask ourselves, does it accelerate if we decrease the mass of an object? Maybe. By increasing the mass of an object? Maybe. By increasing the force pushing on an object? Or both A and C? The key idea here that we have to remember is this. F equals M times A. Okay? Or we can rearrange that formula for acceleration is force divided by mass. Okay, so let's look at this version. How can we make acceleration get bigger? If this is acceleration right here, and our force is big, then acceleration is going to be big. Okay, so C definitely looks like it's going to be part of it. If our denominator here, F divided by M, is tiny, then also acceleration is going to be bigger. Okay, so D is our best choice here. And even if you're not super comfortable with the algebra I was just talking about, the math I was just talking about, just read the sentences and think of examples. It's easier to make something go fast if it doesn't weigh very much. Right? Think about pushing an empty shopping cart versus like a shopping cart with a ton of like heavy bricks in it or something. The smaller mass one is easier to accelerate. Also, it's easier to accelerate something if we increase the force on it, right? So if you push it just a tiny little bit, it doesn't accelerate very much. But if you push it with, like, I don't know, your gorilla strength, it's going to accelerate more. Okay, so both A and C. So we also have this question, give 3 examples of force pairs that occur when you do your homework. I'm not going to give all 3 examples, but let's do one. Maybe pencil pushing on the notebook when you're writing, and the notebook pushing on the pencil. Okay, what I want you to notice there is we've got these 2 words, pencil and notebook. There are 2 objects that are involved. The pencil is pushing on the notebook, and when we write our reaction force, we've got the same 2 words. Notebook and pencil are doing the reverse push. Okay? Action is the pencil pushing on the notebook. The reaction is the notebook pushing on the pencil. So when you've got your other answers here for 2 and 3, you should have your action and reaction kind of look like the sentences I've written here. Something pushing on the other thing, and the other thing pushing on the thing. Okay? Your words, your pairs are the same in the action and the reaction. Okay? Question 4, what does Newton's first law say about objects at rest and objects in motion? Right? Objects at rest stay at rest. Objects in motion stay at motion until you give them an unbalanced force. Okay. All right. Question 5 is asking you to do a math problem. What force is necessary to accelerate an 70 kilogram object at a rate of 40 meters per second squared? Okay. So what force is needed to do this? We're going to need this math formula. So we wrote this on one of the pages in our notes. Fill that in there before you start plugging numbers in. So you should show your work while you're doing this, okay? So we've got that, and that's the same as if we multiply 70 kilograms times 4.2 meters per second. Okay, so in your calculator, you'll type in 70 times 4.2, and you're going to come out with some kind of answer in newtons. Okay, so you guys do that piece of math there, that multiplication, and you'll get your answer right there. Okay, backside. So use Newton's first law of motion. That's objects at rest stay at rest. Objects in motion stay in motion until we get an unbalanced force, to explain why airbags in cars are important during head-on collisions. So first part of this is probably you just imagining what's going on during a car crash when the front of a car hits something and the airbag in the steering wheel pops out and protects the driver from hitting the steering wheel. And so be thinking about objects in motion, like the person, the driver, wants to stay in motion until an unbalanced force stops them. Okay? And so even when the car abruptly stops, the driver in the driver's seat, or the passenger in the passenger seat, is going to keep moving forward until something stops them. And the something is the airbag providing an unbalanced force to cushion them to a slower stop. Okay? And so be using words like an object in motion stays in motion. A person is an object in this case until we get an unbalanced force. Okay. Question 7. Imagine you accidentally bumped your hand on the table. Your hand hurts after it happens. Use Newton's third law of motion to explain what caused your hand to hurt. Okay? So your action force is your hand hitting the table. The reaction force is, importantly, the table hitting you back on your hand. Okay? So when you're answering this question, be very careful about your action force and your reaction force. All right, everybody. I will see you when we get back tomorrow. If you've got any questions, we'll have a few minutes to answer them at the beginning of the hour.